Hi everyone, in this video we will solve example 11.2 from the book Fluid Mechanics by Sanjay. Here the statement of the example 11.2. Two common methods of improving fuel efficiency of a vehicles are to reduce the drag coefficients and the frontal area of the vehicle. Consider a car that is shown in this figure, whose width is and height are 1.85 meters and 1.7 meters respectively, with the drag coefficients of 0.3. Determine the amount of fuel and money saved per year as a result of reducing the car height to 1.55 meters while keeping its width the same. Assume the car is driven 18,000 km a year at an average speed of 95 km per hour. Take the density and price of gasoline to 0.75 kg per liter and 0.95 per liter respectively. Also take the densities of air to be 1.2 kg per meter cube, the heating value of the gasoline to be 44,000 kilojoule per kg, and the overall efficiency of the car drivetrain to be. So all the scenarios and the data has been given in this statements, and the figures of the vehicle is also provided for easy understanding. You can see that the height of the car is reduced 1.55 meter. Why we are doing so? Because to reduce the consumptions of fuel, and to reduce the consumption of fuel, it will obvious that it will give you saving in term of money. So let's solve these examples, and then we see that how much saving we can get if we reduce the height of the vehicle by 1.55 meter. So let's begin it. Well, the drag coefficients is CD, and it is 0.3, 1.85, and the height of the vehicles, and when it is not reduced, it is 1.7 meter. It's also in meter. The drag coefficient has already written. Okay, then the car is to reduce the height. Then we reduce the car height, so it, let's say HN means H new. It is 1.55 meter. Then the car cover the length, so the length means the distance, or L, that it covers per year, that is 18,000 kilometer. Average speed of the car is 95 kilometer per hour. To convert that into meter per second, just divide 95 with 3.6. you will get it in terms of meter per second, and you will get 26.38 meter per second. The density of fuel, that is 0.74 kg per liter. Then price of fuel, that is $0.95 per liter. Density of air, 1.2 kg per meter cube. And the heating value of the gasoline is 44,000 kilojoule per kg. Efficiency of the car is 30. We are basically interested to find the cost saving in order to reduce the height of the vehicles from 1.7 meter to 1.55 meters. It will reduce the frontal area of the vehicles. Reducing the frontal area of the vehicles, it will less consume the fuels, and it will save your money. And we need to find that reductions in fuels saving in terms of money. Solution. What is drag coefficient? First we need to find the drag force, that is equal to CD A density V square divided by 2. Density means density of air, so it is 0.3 multiply with area. Area means that is 1.85 multiply 1.7. Density of air is 1.2. speed of vehicles, that is 26.38 divided with 2. So after solving you will get the drag force, that is 394 Newton. Work done by the vehicle is equal to F drag multiplied by the distance it covered. So F drag, that is 394 Newton. The length distance it covered, that is 18,000. After solving you will get the work that overcomes the drag force that is acting in the opposite directions of the vehicle speed, and it is multiplied 10 to the power 6 kilojoule per year. Efficiency of the car is given and it is equal to work output divided by energy supplied. So the energy supplied is then equal to work output divided by efficiency of the car, and work output is 7.092 multiplied 10 to the power 6 divided by efficiency of the car, it is 0.3, that is 30%. Here it is given. So after solving you will get its value, that is 2.364 multiplied 10 to the power 7 kilojoule per year. So this much energy input is required for these vehicles when its frontal area is equal to 1.85 multiplied by 1.7 meters, when its height is not reduced. Next is to find the mass flow rate of fuel that is consumed per year. So we can say that energy input to the car is equal to mass flow rate of the fuel multiplied calorific value of the fuel. So we are interested to find the mass flow rate of fuel. We can say that the mass flow rate of fuel is equal to energy supplied divided by calorific value. So what is energy? That is 2.364 multiplied 10 to the power 7 divided by calorific value, that is 44,000. After solving you will get the mass flow rate of the fuel that is used per year, that is 537.3. Okay, we are now interested to find the volume. Okay, next we need to find the volume flow rate that is used per year. So the mass density of the fuel is equal to mass flow rate of the fuel divided by its volume flow rate of the fuel. So we are interested to find the volume flow rate of the fuel, and we can say that volume flow rate is equal to mass flow rate of the fuel divided by density of the fuel, because the price of the unit price of the fuel are given in liter in volume. So that's why we will find the total volumes per year of the fuel used. So mass flow rate of fuel is 537.3 divided by density of fuel, and it is 0.74. After solving you will get, then cost of fuel is equal to volume of fuel used, volume flow rate of fuel used multiplied by unit price of fuel. It is V dot F, that is 700. Now in the second case we reduce the height of the vehicles up to 1.55 meter. So by reducing the height of the vehicles we are basically reducing the frontal area. So after doing so it will reduce our drag force. By reducing the drag force, so less work will be done by the vehicle, so it will use less fuel. So less fuel use means you will save energy, you will save money. Reduction in fuel, we need to find the reduction ratio. So reduction ratio in frontal area, and it is equal to A minus A new divided by A, and it is equal to H original height minus new height divided by original height. Original height is 1.7 minus 1.55 divided by 1.7. We'll get the reduction ratio, that is 0.0882. So fuel reduction is equal to amount of fuel, that is VF, multiplied by reduction ratio. So amount of fuel is 726, reduction ratio 0.0882. After solving, you will get fuel reduction, that is liter per year. Less fuel will be consumed. Next is to find the cost reduction. Cost reduction is equal to cost of fuel multiplied with reduction ratio. Cost of fuel is $690, multiplied reduction ratio 0.0882. Multiplications, you will get cost reductions, that is $61 per year. Saving in terms of money you will get if you reduce the height of the vehicle up to 1.55 meter. I hope you understand. If you still have any confusion, you can ask in the comment section. Thank you so much. Subscribe my channel if you haven't subscribed yet, and also share with your friends and colleagues so they can get help from it.